Hey, today we're going to talk about 7.2, photochemical smog. So take a moment and check out the enduring understanding, look at the learning objective, pause the video, review the essential knowledge, and set up your Cornell notes. So photochemical smog is a secondary pollutant, and it is a term, it's a portmanteau, smoke and fog, and it was noticed in industrial London back in the late 1800s. And industrial smog is different than photochemical smog, but industrial smog was caused by sulfur dioxide, which is released from the combustion of coal, and also particulates that are reacting with the water vapor. And it is present in cool and humid conditions because you do need the water vapor. Now, photochemical smog is a little bit different. Well, it's a lot different, actually. It's caused by VOCs, volatile organic compounds. Also, hydrocarbons are examples of VOCs, but also with NOx, nitrogen oxides. And they are reacting with sunlight, or the energy from the sunlight. And the reaction is you need VOCs plus NOx plus oxygen gives you ozone. And I'll go into a little bit more of the chemistry in a moment. The biggest cause of this is from automobile use, and this NOx is released in the exhaust. And it typically would take place in dry and warm conditions. Most notably, it's been seen in Los Angeles, and there is a picture right here, and it has a nice brown color. It's also seen in Beijing, China. Industrial smog was more of a grayish kind of color, and the photochemical smog has a brownish tint. So just to refresh, volatile organic compounds they have a very low vapor pressure, so they easily vaporize, they easily evaporate, and that's why you smell them. They often smell chemically. That's a fancy scientific word, chemically. The only natural source of VOCs, or one of the only natural sources, not the only, but one of the natural sources, is plants, particularly evergreen trees. From if you break a leaf of a pine tree or spruce or whatever, it will have kind of that very pine type of smell. That is a volatile organic compound. But the other ones, I mean, I went over this in a previous video, so this is just a refresher. Now we have nitric oxide, NO, and nitrogen dioxide. It doesn't matter if you don't remember what they are, that's fine. But the equation is for how to produce nitric oxide we get first, and then we get nitrogen dioxide. And I'll go through that in a moment. But nitric oxide, it's colorless, it is flammable, and it has a very slight odor. But nitrogen dioxide is what gives us that reddish brown color. So NO2 has that reddish brown color. It fortunately is not flammable, but it is poisonous and has a harsh odor. So if you breathe in too much of it, obviously you could have detrimental effects. Okay, so photochemical smog, the primary component of this photochemical smog is tropospheric ozone. So they're not synonymous because photochemical smog contains tropospheric ozone with other substances present in it. And to form tropospheric ozone, first what you need to do is you need to have oxygen and nitrogen. The nitrogen, remember, 78%, 80% of the atmosphere is nitrogen, 20% is oxygen. So whenever you are burning fossil fuels in an internal combustion engine, you are releasing nitric oxide, the NO. Now, combine that with energy from the sun, and also a little bit of influence from these volatile organic compounds. What happens as a result, because these volatile organic compounds are photooxidants, so they also help to perpetuate the formation of nitrogen dioxide. And this is the one that has the reddish brown color. And this is one of the main components of, or one of the main precursors to photochemical smog. So once you have this N2O and you add a little bit more sunlight, what is happening is you're giving off one of these oxygens. And this NO2 is not as stable, so it easily gets rid of that oxygen when you get some sunlight. And what happens is this oxygen is very reactive, and it will go and react with oxygen from the air and form ozone. Now this happens when when two things are present. You need to have sunlight, you need to have cars. So when is that happening? During the morning rush hour especially. That is when we're generating a lot of these nitric oxides and nitrogen dioxide, which are then leading to the formation of tropospheric ozone. So the smog formation, we can have the natural sources of these VOCs, and then we have the anthropogenic sources, which is from the combustion of fossil fuels. And following the steps that I've showed you before, we can contribute to tropospheric ozone. But to get to photochemical smog, you will also have other photooxidants like peroxyacetyl nitrate, or PANs. Now, do you have to understand the chemistry of this? No, but if you ever see PAN, it is a component of photochemical smog. That's why I put this in this video. It shows up on a few of the multiple choice questions. It shows up as a pollutant, so it is an option that you could put for questions pertaining to photochemical smog or components of photochemical smog. And one of the impacts is this tropospheric ozone can go into the stomata. Stomata, remember, are the small holes on the underside of a leaf, and they allow for gas exchange. Well, the tropospheric ozone goes into those pores, and it oxidizes the tissue in the leaf. So it's kind of killing the plant by killing the leaves from the inside out. So it can definitely harm plants, but for humans, it's also an oxidizer, and it's a heavy irritant, so it can irritate our respiratory system. So it can irritate the lung tissue and cause respiratory ailments. Now we have primary versus secondary pollutants. So based on the time of the day, the first things that come out of the car are the primary pollutants. And photochemical smog is an example of a secondary pollutant. So the primary pollutants, you'll see them showing up in the beginning of the day. The VOCs and the NOxs, they are released from the operation of internal combustion engines, from the operation of motor vehicles. And then after it has a little bit of time to react with the sunlight, what we get is we're going to see another peak of pollutants later on in the day, and that is from the smog, and also you may see aldehydes as well. Aldehyde is just another organic substance, and to be quite honest with you, this you could put in this graph, you could put photochemical smog, you could put tropospheric ozone. I've seen aldehyde show up, but you don't ever have to know the chemistry behind it, so that's a benefit. So how can we reduce photochemical smog? Well, first of all, here's some of the impacts on humans. You can have stroke, depression, that would be in your nervous system, heart attack, any sort of cardiovascular system will have issues with your heart. Asthma, lung cancer, bronchitis, all can be exacerbated or made worse by photochemical smog. You can get skin cancer. It is an oxidant, so with enough of it, it could lead to skin cancer occurring, and also nerve damage. So how do we get rid of this, or how do we reduce it? Well, first of all, drive less. Makes a lot of sense. If you don't have the NOxs and the VOCs coming out of the cars, then you're going to have less ingredients to make this smog. I would say take care of cars. Like if you improve the gas mileage and you reduce their emissions, that will enable your car to operate more efficiently. If you add fuel during the cooler hours of the day, you will be contributing less, because there are VOCs that are present in gasoline. So if you're fueling up during the warmer parts of the day, you're releasing those volatile organic compounds into the atmosphere, which is just giving more ingredients to make the smog. Avoid products that release high levels of VOCs. You can find alternatives, especially when we're talking about cleaning supplies and other substances that have high levels of VOCs. And also avoid gasoline-powered yard equipment. Like electric lawnmower would be better than gas-powered lawnmower. Granted, with the electricity, we get our electricity from coal-fired power plants, so there is a little bit of an impact there. But if we're talking just about photochemical smog, if you reduce the gasoline powered yard equipment, that will help eliminate or reduce photochemical smog. Get a hand powered lawnmower, especially those of us that live in New York. Like, who has a big yard that you need a driving lawnmower? You don't, right? So that's what you could do. All right, so for your FRQ practice, what I would like you to do is look at this graph, and I would like you to describe how ozone formation changes based on the time of day. I thank you very much for your attention. I hope that this video was informative, and I will see you soon.